Hello, everybody. Welcome back to the train wreck that is a deep astronomy live stream. Something's going to go wrong. You can just count on it. My name is Tony Darnell, yet another white guy mansplaining astronomy on the internet. Today, we're going to talk about a lot of cool things. Notably, we got big news on JWST. You guys, if you've followed any NASA Twitter tweets and you follow their press releases, you already know what it is. But we are getting ready to talk about both that news on JWST as well as the Lucy mission. And the reason I named this stream what I did, have you heard about the Lucy mission? I have to confess, I did not. So I frantically learned about it. Why? Because it's launching on Saturday, and I needed to know what it was about. So we're going to get educated, both of us, on what this mission is, because I can look things up on the internet and explain them just as good as the next white guy. So I'm going to do it. Sorry, I just was noticing that the other day, just how many white guys there are doing astronomy on the internet. So I'm just one more of them. So thank you for hanging in. Thank you for joining me in my stream. And the format of this thing, this catastrophe on the internet, is I pick a topic on something that interests me. In this case, Lucy, the Lucy mission. And then I talk about it for about, I don't know, however long I feel like it. And then afterwards, we have a conversation about it. We talk about it. And I am streaming to make that as easy for you as possible. I'm streaming on all of the social media channels that I have accounts on, including Twitter, Twitch, and YouTube, and sometimes LinkedIn if they're nice to me, and of course Facebook, which nobody watches because Facebook is. I have one guy I think that watches on Facebook, Dennis, and he watches in spite of all the obstacles Facebook throws in the way. I don't pay money for this, so nobody gets notified that it's happening. So I'm monitoring all of the different streams in that regard. But here's the thing: the cool thing about the internet, one of three things that are cool about it, is that I can also talk to you. If you join my Discord server, which I put a link to in the description box of most of these platforms, go there, join the live stream voice channel on there, and I can hear you through these and we can talk. And when I push the button on my mixer, you are being streamed. So we can have a conversation. It's like an actual call-in show back from the days when telephone was when telephones were a thing. So hopefully you guys can hear me okay. And I'm waiting. Let me go look at my chat just to make sure. It looks like okay, Galaxia, hey, that's good to see you. Kinslayer on Twitch and various other lots of people on Twitch actually. Well, to be fair, this was called Tony's Twitch Tuesday for a long time. I decided to just click on the YouTube button and go ahead and send it to YouTube as well. So it goes to YouTube now too. Dan from Canada's here. It's good to see you. Had a memorable show last night with the Northern Lights. Let me just put that up because that's really cool. Good day, all. Had a memorable light show late last night with the Northern Lights. Should have again tonight. I believe, if I'm not mistaken, Dan, there is a CME either on its way or having hit. I saw something on spaceweather.com, I think, where we are to be interacting with the solar wind quite a bit over the next few days. So it's cool that you're seeing the Northern Lights in Canada. I don't see them here in Florida very often, but Canada's prime spot. Ebone from Twitch. Hey, everybody. It's good to see you, Ebone. I'm glad you're joining us. Galaxy, as always, it's a pleasure to see you. And the upcoming Psyche mission is pretty interesting, too, especially if they find out actually an exposed protoplanet core. You know what? Thanks for the idea. Let me write that down. We should talk about that. Psyche mission live stream. Also want to give a shout out to Julian, my friend who is I believe he's also Canadian, who I chatted with earlier today on Zoom. He just wanted to say hi, and he's been giving me lots of good feedback on what he thinks of the content. So thank you, Julian, for chatting with me today, and also letting me pick your brain on some other things as well. So thank you very much. Cryptolicious, it's good to see you. But I wonder if he had to say that you're to save face per huge expense in the big ground. Oh, you guys are talking about Elf? What are you guys talking about here? Let me. Oh, I don't see the beginning of that. Not wanting to be done by the far more affordable Elf. Okay, you guys are talking about something I don't know what that is. So I've joined the conversation late. So I've learned the hard way not to get into conversations you don't know what's about. Okay, first up, everybody, big news, everyone. Let's talk about this first. Today, this just came out on the intertubes with from NASA's press release. The Webb Space Telescope is now in French Guiana after a lengthy sea voyage. Look at that magnificent ship that it arrived on, a container ship full of our hopes and dreams and $9 billion worth of science, hopes and dreams. And it arrived today. It got there. And so they're going to get it, I guess, off the ship and into the rocket very, very soon. Scrolling down the press release, I will say that let's just read what they say real quick. The MN Colibri, that's the name of that container ship, departed Seal Beach, California, Sunday, September 26th, and entered the Panama Canal on Tuesday, October 5th, on its way to Kourou. The ocean journey represented the final leg of Webb's long earthbound travels over the years. The telescope was assembled at NASA's Goddard Space Flight Center. Yeah, we know all that. We know all that too. We know all that. Okay, so Webb was shipped to Space Park in California, where for 3 years it underwent rigorous testing and dropping of bolts to ensure its readiness for operations in the environment of space. So Thomas O'Buchan said some nice fluffy things. And then next up is after Webb is removed from its shipping container, engineers will run final checks on the observatory's condition. Webb will then be configured for flight, which includes loading the spacecraft with propellants before Webb is mounted on top of the rocket and enclosed in the fairing for launch. Oh boy. And let me just finish this with what Greg Robinson, the Webb program director at NASA HQ, says, quote, Webb's arrival at the launch site is a momentous occasion. It's also one that causes a lot of relief, like no pirates, right? We, to continue the quote, we are very excited to finally send the world's next great observatory into deep space. Webb has crossed the country and traveled by sea. Now it will take its ultimate journey by rocket 1 million miles from Earth to capture stunning images of the first galaxies in the early universe that are certain to transform our understanding of our place in the cosmos. For more information about the Webb mission, visit www.nasa.gov/Webb. So there we are, everyone. Webb is safely ensconced. It's to the extent that you can be safely ensconced in French Guiana, Kourou, where they're going to load it up. So it got there. No pirates. A bit disappointed in that. I would like to have seen an attempt made, at least, but no. This is a good tip. Thank you, Galaxia. For questions, please use that question mark so I can easily pick your question. There's not so much going on that I won't be able to check it, but it's always, I'm not one of those guys where the chat just flings by. But thank you, Galaxia. That is a good thing. A good piece of advice. Okay. Excuse me. Let me pull up my little slide thingy and present. Okay, let me turn it on. Okay, so here is I put together a few little slides to talk about the Lucy mission, a mission that launches this Saturday, the 17th. So it's going up. And boy, you want to talk about a tribute to Isaac Newton. Wait till you see this orbit, man. It put everybody's skills in calculating Newtonian orbits to the test. You'll see what I'm talking about here in just a minute. But so this is the first mission to the so-called Trojan asteroids. And these Trojan asteroids are this swarm of things. You see them in this animated GIF here off to the right. These groups of green, based in between these two groups of green is the planet Jupiter. And there are Lagrange points, stable orbit configurations on either side of Jupiter, where these things tend to congregate. They are believed to be remnants of the early solar system. So these Trojan asteroids are incredibly difficult to get to, it turns out, but it is being planned out and has been planned out for a launch coming up. So this is those green blobs there are the so-called Trojan asteroids, and Lucy is going to fly to 7 of them as it goes in and out of those 2 swarms. So this is what the mission is planned to do. There's one swarm, there's another swarm, there's the planet Jupiter right there, going round and around. I did not know this, so this is all new to me. Lucy mission will look at the surface geology using cameras. It'll also look at solar surface color and composition of these asteroids, also using cameras, interiors and bulk properties using spectrometry. They got spectrometers on board, and it will look for rings and satellites also in orbit around the Trojan satellites, or the Trojan asteroids. So that's pretty cool. Here's some specs. Thing weighs about 1,500 kilograms, all fully fueled up. It's about 16 meters wide, 7 meters high. It's got 500 watts of power coming from solar panels. These will be the power generated at the furthest encounter that it has, when it's the furthest away from the sun. I just did a copy and paste on from the website on some of these instruments that it's going to have. It's going to carry 4. It's going to have LRALF, I guess is the way you pronounce that. It's a visible color imager. It's the multi-spectral visible imaging camera. And it'll look at the wavelengths from half a micron to almost a micron. And it'll have an infrared imaging spectrometer, which will have an etalon on it that looks at 1 to 3 or almost 4 microns. And it will also allow them to look for absorption lines that serve as fingerprints for different silicates. So this is the interior parts that we're going to be looking at. They're going to be looking at ices and organics that likely will be on the surface of these asteroids. Okay, so that's one instrument. The other one is LORI, the long-range reconnaissance imager, and it's a high spatial resolution imager. This is their main camera. It is panchromatic, covering wavelengths from 0.3 to 0.8 microns, 0.9 microns, and it will provide the most detailed images of the surface. And then you have this other one, this thermal emission spectrometer, which is similar to instruments that were on OsirisRex and the Mars Global Surveyor. Remember, OsirisRex went to Bennu and landed, or not land on it, but blew on it and got some stuff from it and sending it back to Earth. This is an infrared spectrometer that looks from 6 to 70 microns. So this is going to be looking a lot at dust particles and some of the composition of the surface that way. And it'll look at their thermal inertia. I don't know what a thermal inertia is. Oh, how it says right here, how well bodies retain heat, which teaches us about the composition and structure of materials on the surface of the asteroids. So those are 3 of the main interests. And additionally, they added that it is also got a high gain antenna, but I don't know why they include that, because all these things have a high gain antenna. But I see why, because it's going to look at the Doppler shift of the radio signal to get the masses. So that's why. That is why it is considered an instrument. So very good, Tony. Read the thing. Okay, so there was a mission trailer I wanted to show. I was going to show this one, but I don't like it as much as this other one I found, so I'm going to show this one instead. So let me turn.
NASA's Lucy mission is going to be the first.
Push pause on that. So all right, I want to make this embiggened. Give me a second. Push this button. All right, here we go.
NASA's Lucy mission is going to be the first mission to explore the Trojan asteroids. These are asteroids that live in 2 swarms, one that's ahead of Jupiter and another that's behind Jupiter. And we want to go and look at these building blocks of the planets, the ones that didn't get accumulated into the planets, to really learn about the evolution of our solar system.
Lagrange points are these stable regions of space. They're around pretty much every planet in the solar system. Jupiter, by virtue of being the largest planet in the solar system, it also has the biggest Lagrange points. And these are little stable reservoirs where asteroids get in, but they never come out. In reality, what we have is sort of a snapshot of what the solar system looked like billions of years ago.
Early in the solar system, the giant planets were migrating outward, away from the sun. And at one point, there was chaos in the solar system. Some small bodies were ejected out of the solar system. Others could have been trapped in these Lagrange points. And that's one theory for how the Trojan asteroids came to be where they are today.
My job as a mission architect here at Lockheed Martin, it's very interesting, and it sort of encompasses the biggest picture of the mission. What is the trajectory? What sort of propulsion do you need to fly that trajectory? What does the spacecraft look like? So in the case of, for example, Lucy, it's like, okay, it's going out 5 times further from the sun than the Earth is. And so it's going to need big, huge solar arrays just because of that.
Lucy has 3 scientific instruments on board the spacecraft, and we'll also be using 2 of the spacecraft subsystems to contribute to the science investigation. With the LORRI instrument, we'll be able to get panchromatic images, which will tell us about the geology, and the crater history, which gives us the age of the surface. With the TESS instrument, we'll be able to measure the temperature of the surface at different points, and with the RALPH instrument, we'll be able to measure the composition of the surfaces. The Jupiter Trojans, they have a variety of surface characteristics. They have different colors and different surface compositions, and that leads us to believe that maybe they formed somewhere else. In choosing the Lucy targets, we wanted to be able to compare different objects that have different surface properties, but a very similar orbit. Lucy will visit 1 main belt asteroid and 7 Trojan asteroids.
I don't think there's been a single NASA mission that will have visited as many objects on separate orbits in the solar system as the Lucy mission will. We launch in October of 2021. That trajectory just basically does a 1-year loop around the sun and comes back to Earth in October of 2022. And that will slingshot us out now onto a trajectory that takes a little more than 2 years to come back to the Earth. Now we're moving a whole lot faster than we were. We get that trajectory set up, and that second Earth gravity assist takes that velocity and redirects it in the direction we want that'll take us out to the Trojan space.
On our way out to the L4 swarm of the Trojans, we're going to visit a main belt asteroid. That main belt asteroid is named Donald Johanson after the discoverer of the Lucy fossil. We named the Lucy mission in honor of the Lucy fossil because we learned so much about hominid development and evolution from that fossil, just like we're going to learn about the solar system evolution from the Lucy mission.
From there, we take a couple years off and we continue to cruise up until we get to August 2027. And there we encounter our first Trojan asteroid. It's called Eurybates. It's the product of a huge collision that happened millions and millions of years ago. Something big hit it and just blew it apart. And so Eurybates is the biggest chunk of that cataclysmic impact. And it's a C-class asteroid, which is kind of interesting because there's a lot of C-class asteroids in the main belt. There's very few of them in Trojan space. So that's one of the mysteries we're going to get at is, okay, why is Eurybates so different? As we've studied it and tried to refine its orbit, we've discovered it's got a little moon. And so we're going to try to get pictures of that too as we fly by. And about a month later, in September of 2027, we're encountering our second Trojan asteroid, Ptolemy. So it's one of the smaller objects. We're flying by at about 6-7 kilometers per second. We have to take pictures like crazy as we fly by, but we're not stopping at any of these. We come to our next object, Lucas. It's wash, rinse, repeat. And so we snap pictures like crazy at Lucas. And then about 7 months after that, we do the exact same thing at another object called Oris. And that's the last L4 swarm object that we're going to be visiting. And from there, we start dropping down back into the inner solar system now. So we were out past Jupiter's orbit a little ways. Now we're falling back in towards the Earth. So the trajectory is sort of set up to sort of return back to Earth for free. And we use that to redirect the trajectory now towards our final Trojan asteroid. And so this is an object out in the L5 swarm. So it's trailing Jupiter by about 60 degrees. It's a roughly equal mass binary system called Patroclus and Menetius. You can imagine it's sort of like this dumbbell in space. So imagine a great big dumbbell spinning around, but there's no bar there. It's just the objects orbiting each other. It's a very rare thing to find in the inner solar system. However, if you look out past the orbit of Pluto, equal mass binaries are kind of common out there. Another clue is like, okay, are these objects in the Trojan swarm, are they maybe related to the Kuiper Belt objects out there past Jupiter? And if they are, this will be amazing. We can go and visit Kuiper Belt objects by just going out to Jupiter.
We really have never seen Trojan asteroids up close before, and we want to understand their geology. Look at the craters on the surface to understand the history of their surfaces, understand the composition of their surfaces so that we can maybe learn something about where they formed. And all of those will be clues to help us understand how the solar system evolved.
I had to unmute myself so it didn't come through twice. I mean, so that's a pretty good overview of the mission itself. You gotta end. I mean, I agree with you, Dennis. Look, I mean, you gotta love how these gravity assists work. That trajectory is crazy. I mean, that is something. Let me just see if I could pull this up again. That
Out in the L5.
Let me turn that down. Let me mute that. And you go back to this thing. And you check this out. This is like, what? I mean, first of all, you've got that. And let me hide this. So, I mean, that is, that is pretty crazy. But then you're going forward and you go around, you hit the Earth a third time. This will be the third flyby that Lucy has with Earth. And then it will sling it in like, boom. And then off it goes out into this Patroclus one, that binary system that's orbiting in that cloud over there. I mean, that is a crazy trajectory, man. I mean, Isaac Newton would most definitely be proud of that because of all the stuff that's involved in getting there. So it's going to be, you got to be patient though. This mission is going to take a while. We're going to be into the 2030s by the time we're all done with most of this stuff. Let me go back to my slides. I think I got one more left. Yeah, okay. So that was the mission trailer. That one was a little bit shorter, but I didn't like it as much.
The Lucy mission is going to fly past 7 hours.
I don't want to actually see it. There we go. Okay, so here's my final slide. So here's a bit of a crazy graphic they had on their website about showing all of the places it's going to go, all the way out first out to the L5 and then L4 Trojans out this way, or is it the other way around? I think it's the L4 and then goes to L5. It does all these crazy gyrations around the Earth, 3 Earth flybys all together, and it's going to be well into the late 2020s and early 2030s by the time this thing will all be done. All of its flybys, including the Donald Johanson flyby in 2025. That'll be the first one that it hits after launch, which, as they said in the video, they named it after Lucy, the creature, the fossilized remains of one of the first humanoids found, and it was, I guess, in homage to the fact that we learned a lot about the human species from that. We'll learn a lot about the origins of the solar system from this mission here. So that's Lucy. Brief as it gets, introduction into the mission. I see some of you are in the live stream voice channel, so go ahead and I muted you, by the way, Tony, because we could hear you, man. And so I muted that. But the rest of you, go ahead, and if you got something to say, just say it. And I'll also be looking at the chats as well. Anybody? WJR? W. Rasmussen? You got something to say? No, you're just listening? Okay. Whoop, he's out of there. He's like, no, oh my God, he saw me. Okay, well, if you guys want to add to it, please do. Let's get to some comments here. Too bad Lucy isn't carrying some drones and grab and return samples. Well, that adds quite a bit of complexity to the mission, doesn't it? So as we saw with OsirisRex, as well as the one that went to oh shoot, I forgot the other asteroid. It was a Japanese mission that went. Hey Raj, it's good to see you. I wonder what the distance would equate to if it was a straight line. Yeah, that's quite. They could be traveling quite a bit. Dan wants to know, where are they launching Lucy from? Oh, that's a really good question. Let's find out, shall we? Let's see. I'm looking. So here is Swiri's web page, mission timeline. Let's check that out. Back to 2015. Let's fast forward to 2021 October. Lucy's launch period spans 21 days. In the autumn of 2021, each day there will be a window in the morning when the spacecraft can launch. Well, that's good, but that's a good point. I don't know where they're live. I don't know if it's from Kennedy or not. Let's try again. Lucy, launch, location. Cape Canaveral, so it'll be here. Here's some facts. What are the Trojan? What does it stand for? How can I get involved? When will Lucy launch? And where will it launch? So it's going to be from here in Florida. I wonder what time. It's going to start at 5:34 a.m. on August 16th. I don't know about that. I might get up. So there you go. It's going from Cape Canaveral. And let's see. Yeah, thank you for following. Cyanophyte. I appreciate it. I appreciate that.
Of course, at 5:40 a.m. Eastern Time, the day has already well and truly begun. Yeah.
Right. So you could see it no, you couldn't. Not if you lived here, because you'd have to get up at 5:30. That's right, Peter.
If it was coming towards we would still not see it.
No, that's true.
Which is a shame.
Yeah. And Vibe 3S is commenting, I am not looking forward to that 3-week deployment phase. Talking about JWST, I know that's going to be a very difficult time for all of us, for sure. I was seeing somebody, I think it was Emily Locked-Wallace tweet or something, saying she won't be watching it. It's just going to be too scary. And Serial Port is like, I won't believe this until I see it, until you see first light. So, yes, I know a lot of us are getting kind of cynical about JWST and whether it actually is ever going to see the cold of space. John Suffel is like, I hope they remembered to check all the bolts are tightened up at Goddard. Well, it's too late for that now. Yeah, what's left is filling it with fuel and packing it up. I think they're going to do some checks after they unload it from the container. They're going to do some electronics checks, things like that. So. Get some video of the Lucy launch. You know, the thing about my being able to get video is I have to be several miles away, Dan. I'm going to be, when I watched the Inspiration 4 launch from SpaceX with Charlotte, and it was beautiful. It was about 6-7 o'clock in the evening, just as twilight was hitting. And I was still 3 or 4 miles away. I can't get any closer than that. And, you know, NASA and all those guys, SpaceX, all those guys, they get right there on the launch. So they live stream it, and you really can't get a better view than that. The only thing I could give is we could, you know, maybe spend some time chatting about it prior to the launch. But I can promise you, based on all of my experiences with all of my launches, the minute a launch gets anywhere close to happening, that within 2 minutes of launch time, throughput and the internet goes to crap because everybody's live streaming their self on video on Facebook and everything else. So all the cell towers get bombarded with stuff.
your best bet is to look for Tim Dodd, or I've found Angry Astronaut does a lot of launches.
Yeah, so some people get special access, or they get better bandwidth. They have special ways of. I mean, I could, if I wanted to spend the money, I could get bandwidth, but I can't afford it, so I don't
And
do
if
it.
you don't know the Angry Astronaut, he's exactly what he says on the tin. He's got a anger meter in the corner. And if he gets a little bit too annoyed at things, he'll move it along or move it back. Have a look for him.
Okay, yeah, I've not seen it.
It's slightly
There's
different.
so many people streaming. I mean, it's like so many people doing this, right? There's also the other. What was the other guy? The Everyday Astronaut. He does it too, right?
Yeah,
And
Tim Dodd.
yeah, and the guy that does Kerbal Space Program. That guy, I forget his name too. He does a lot of it.
Scott Manley.
No, not Scott Man. Well, him too, but he doesn't live stream
Yeah,
launches.
he does.
There's another guy.
California launches.
Yeah. No, this guy he's on the East Coast. I forget his name now. Valdez. Does that sound right? Das Valdez.
Das Valdez.
Yeah, he does it too.
They get all of the
so
SpaceX and NASA
plenty
streams.
of people doing that crap. You don't need me out there doing it. Arcatufus is commenting, probably probing an asteroid would equate to equipping the probe with a Swiss Army knife. Probably will increase the mission capacity by a factor of 10. Yeah, I wonder what this mission's costing. Let's see if it says anywhere. Lucy mission cost. $981 million.
Yeah,
the total cost. So this is drop in the bucket.
Drop in the bucket compared to JWST.
It's not named after Lucy in the Sky with Diamonds. What am I reading here? This is the Hindu.com. Okay, what is this? All right, this is like for now. It's like what? Whatever Lucy finds will give us vital clues. This isn't. Okay, this is very different than what I just saw.
Let's hope.
This is what I just saw.
If we are going with a musical theme, let's hope it's named after the Elton John version and not the Beatles version and not the William Shatner version.
Hey, did he go into space? Did he get launched?
I think it's been delayed.
Oh, okay. He's 90, you know.
I know.
90-year-old William Shatner.
He was accepted. He was completely accepted last week.
But it hasn't gone. He hasn't gone up yet. I don't pay attention to.
These guys. Yeah, it's been delayed.
Okay.
Let's have a look.
But you're right, Arcatufus. That would increase the cost quite a bit. We're almost at $1 billion though for this mission. But that's probably a lot of it is going to be for operations, I'm sure, going up. So, but yeah, you're right. It adds a lot. It adds a lot.
I mean, considering I'm not sure breaking the record so soon after Wally Funk is a good idea, but if it has to be anybody other than a test pilot who should have been an astronaut, it should be a Star Trek actor.
Why?
Because Star Trek got a lot of people into science and engineering and even NASA. And a NASA astronaut has appeared as a cast member on Star Trek. So,
well, it's a nice gimmick. I mean, it's a good thing to do because it gets people involved, but I don't think it has to be,
Well, for everything Star Trek's done for science and engineering by bringing in all of these young people into it because of Star Trek,
Mm-hmm.
William Shatner, though, he's not the greatest.
It'd be a pretty bad publicity stunt
in Star Trek
if he doesn't make it. So hopefully
George Takei, maybe, although a lot of people don't like him.
Okay, let me get to a question on Cryptolicious. What if we sent
Stewart? Fairly unassuming.
But they're all really old. Sending 90-year-old people into space probably is I don't know. Anyway,
Will
Will Wheaton. Right.
Well, he epitomized the young, bright, hopeful science and engineering student, didn't he? Really, somewhat.
Yeah, I guess.
Who was overly eager.
Yeah. What if we send a sample taking probe ahead of Lucy and get Lucy to just return it to us? Well, I think you saw Cryptolicious getting there is going to be pretty adventurous, right? So, I mean, I don't think you could send something ahead of Lucy and then, do what grab something, throw it up for Lucy to catch, and then bring it back. Besides, Lucy's, you don't just add mission capability like that at the last minute. Lucy's set. Lucy's been set for what it's going to do for probably years now, and it's just been being tested and getting ready for launch. All of the decisions that a mission has to undergo, like what it's going to do, happens years and years before it's actually launched. And these are called the science requirements, right? These are the things that, what do we want to learn for this, in this case, $981 million? What are we going to learn, and what are we going to put on this thing to learn those things? Then they sit down and they meet and they talk and say, okay, we want to learn about the what these things, are made of, what they look like up close, what their composition is, and we want to see and fly by as many of them as we can. So all of those things that they've put in with the mission requirements, which I put on that one slide, decide what gets built later. And it was never meant to be a sample return mission. That was OsirisRex. That was the first one that was designed specifically for that. And the same is true for, I think, what Perseverance is doing now on Mars. It is grabbing or at least it's grabbing material and putting it into vials, and then it's done one already, and then leave those samples on the surface for a later rover to come along and pick up. So that's an example of doing what you're suggesting with Lucy. They're doing with the Perseverance rover right now. Perseverance can't send things back, but it can lay these vials down on the ground, and then later on they're going to come and grab them with something else that they haven't built yet. So that's the kind of thinking that has to happen. And John is commenting, Lucy will travel almost 4 trillion, is that trillion? No, billion miles before the end of its mission at a cruising speed of 39,000 miles per hour, and will be passing the Trojan asteroids at an average of 15,000 miles per hour. Thank you for that. I was going to look all that up, but then I just ran out of time. So yes, that's going to be a long, long way, and very fast too. Okay. Oh, and here you go. You've also got Antron Petrov covering things too. So there's lots of people covering launches. So you don't.
He just does short videos from home and not live launches. I'm not sure if he's actually done a live yet.
Oh, okay. So yeah, that was good. Thanks for that, John. I appreciate it. Let's see. Raj is commenting they could use solar sails. Well, hold on. They could use solar sails or solar sails and electric propulsion to return these samples. Yeah, you guys are into samples right now. I think that is pretty that's pretty advanced stuff you're suggesting. So I mean, yeah, they could use those things, but you'd have to find this stuff. Oh, I see what you're saying. Grab that, return the samples, and then use solar sails and electric propulsion to return them. Well, it would have to be electric propulsion, because if you use solar sails, it's going to push it out away from the sun, and we need to bring it in closer to the sun towards Earth. So it would have to, using the solar wind, probably wouldn't be the way to do it. Okay, go ahead, Peter.
It's the other Tony.
What? You want to say something, Tony? Hello? Okay.
I hear you.
I don't hear anybody. I hear Peter, and that's it.
Oh. Tony, the other Tony's speaking, but you can't hear him, and I can.
I think it's because I muted him. I had to mute you earlier. Let me unmute you.
Yeah.
Let me unmute you. There, I unmuted you. Sorry, Tony. I had to do that because you were coming through when the video was playing.
Yeah, I know I was. Yeah. So I realized that afterwards. So
Yeah.
yeah, but these are like Pathfinder missions, right? Both what they're doing on Mars there, right? They're seeing if they can actually do this. I mean, I mean the the Trojan asteroids are so far out there. I mean, it's not like with OsirisRex where we were talking about relatively near to us,
In an
right?
AU.
Yeah, and it's we're going out 5 AU there, and in order to get there, we're using gravity assist, not like with Osiris where you know we're close by and we can use the solar arrays to do propulsion. We're using your solar arrays just to power the spacecraft, which is you're probably doubling the size of the solar arrays in order to get enough power to actually, and then you have the propellant involved there so that you can actually stop and rendezvous. I mean, we're going to take pictures just like we did with New Horizons,
It'll be a lot more
and
like that. Yeah.
yeah.
This is,
Like I appreciate that they're doing this fast and cheap, so to speak, but and we're going to get some really good pictures, and we're going to have some idea of what we're going to deal with if we ever want to do. We'll obviously want to do a sample return, but that'll be after we've scouted out the area. We've got nothing out there. We've never flown anything out there
Yeah.
so far.
Yeah.
I
That's right.
mean, there's no actual mission planned for sample return from Mars yet either, even
That's
though
not
the
true. The
groundwork's been laid.
Perseverance was planned. Well, it personally isn't one, or it isn't a sample
Yeah,
return mission itself,
there's no set
but that's part of its science goal
sample
is
return.
to lay things down
Yeah.
on the surface of Mars that can later be picked up easier. And
Oh,
Perseverance
but
has the digging
at the moment,
tools
we haven't
and the drilling
really
tools.
got the capability.
We have Perseverance has the drilling tools and the collection tools to put it into materials that later all we have to have next is a rover go get it, pick it up, and then join up with something that takes off. And that we've never done.
Yeah.
That
Yeah.
that is,
That-
I guess, about as Pathfinder a thing as you're going to find is something that hasn't been launched from Mars and back to Earth. That'll be the one thing we haven't done. But think about it. NASA's got all this other stuff down. Rovers, we can do that.
yeah.
Landing on Mars, we can do that. Driving around, picking stuff
Helicopters.
up, we can do that. It's just launching back up. Helicopters, that's right. We can fly on Mars now, so we can do all this stuff. So, yes. So, I mean, it's not a okay. Maybe that last bit is a bit. You might want to call it a Pathfinder, something NASA's never done before. But everything else is a combination of things that NASA has done in various points in the past. So,
I mean, the Starship's almost ready to test. The SLS is almost ready to have an orbital test as well. So, it's closer than it was when Perseverance was launched or even thought of.
yeah, I don't know what role either of those will have, if any. But yeah, I think what happened. I don't think you're just gonna be able to take Starship out there, or SLS. It's going to need something special built, that's landed on Mars, and then takes off from there. Okay, let me just get to a comment from Ebone. Please remember how much time it took OsirisRex to grab a sample. It's not so simple, and especially when you do not know the surface characteristics of the asteroids. That's a really good point. I think OsirisRex hovered over Bennu for a couple of years, maybe, or at least a year before it actually touched anything. And then there were a lot of people taking high resolution or looking at high resolution photos of the surface to try and figure out the best way to approach it. And then it turned out to do a little bit too good of a job, right? It went down, it puffed out its air that was, this compressed air that came out and captured like too much stuff came up into the little container, and they couldn't close it properly. And they were like they got way more than they had intended to get. And that was after studying it for a very, very long time. They still, got a little bit out of their parameters there. So you're right. This is a
At
hard
least
thing.
we know the terrain and everything, because Mars is very well mapped, just like the Earth or the Moon.
Yeah.
Yeah, because they've got orbital, well, almost GPS
We have
type
a
satellites,
yeah, we got quite a bit of
or
knowledge
Google Earth
of
type
Mars.
satellites.
Hmm.
So, hey, so Tony, I was talking to a friend of mine,
Okay.
neighbor, and he was mentioning that what they did to land on Mars, okay, was pretty freaking complicated. And as a matter of fact, I don't know whether I think we're talking about the same order of magnitude of difficulty, or maybe even less than the sky crane and everything, where your timing and everything is in dynamic uh, flux when you're landing on Mars, especially the way that they're doing it with the Curiosity and Perseverance. And when you compare that to what they're doing with JWST, it's it,
Yeah.
it, it a little bit of confidence. If they can land on Mars with the Curiosity rover and
NASA's
the Perseverance,
NASA.
then yeah, JWST, a walk in the park.
I know NASA got balls.
Yeah,
They do, man.
should be.
They got some nice hexagonal shaped balls to do that stuff. They're right. I don't know. I think this is more complicated with JWST. If I had to pick one, JWST is harder. Just because there's so many single points of failure, so much writing on the mission. Yes, a lot had to happen for a Perseverance rover to make it to land on the surface okay. But I don't think it was as much. It just feels like a whole lot more has to go right for JWST than for Perseverance to land safely. I don't know.
It's just
It
that
is hard.
it ups my confidence level. That's all.
Oh yes. The
If they
fact
can
that
do that,
that's
if
right.
they
The
can do
fact
that, then yeah, we're well, at
the fact
least we've got a chance, right?
exactly.
It's not
Yeah.
like we haven't done something of similar complexity, right? And when I say we, it's not me, but
Yeah. No, I hear you, man. No. You mean you didn't do it? Oh,
No, I
you
have got
misrepresented
very little to
yourself,
do
man.
with it. I just follow it on
I know, yeah.
YouTube and whatever.
Oh, yes. Okay. So let me get to Serial Port's question. Will flyby imagery be used as a way to improve image analysis and spectroscopy from Earth-based telescopes and HST?
Yeah.
Let's see if I can understand that question. Will flyby imagery be used as a way to improve image analysis from Earth-based telescopes?
Well, it'll improve the images because they'll be able to combine them.
Yeah, I don't know that it's going to do anything all that different than what happens with Earth-based telescopes, though. I mean, it's going to take a lot of pictures, going to take a lot of spectra, send it all back with the high gain antenna. Going to measure the Doppler shift, as we said, about their masses and thermal, what they call it, inertia, whatever it was.
Yeah.
And they're going to do all of that.
The
But whether it will improve what we do on Earth or HST, I think it's going to be different. Everything that they do is very mission specific, and so image analysis and the image processing that you would do for an extended object like an asteroid is a little bit different than what you might do for point sources like stars or spectra from stars. So I don't know. It's a interesting question. My feeling is that it's not going to do anything to improve their ability to analyze images that they're already doing. It'll just be another source of data. Image analysis is
Yep.
pretty much a known. I mean, there's a lot of
we've
advanced.
got that tied down.
Yeah, so I think we're
I
okay.
mean, amateurs can do it.
Huh?
Amateurs can do it.
Yes, they can.
Cosmo
specific
Quest was doing an Earth map thing, and well, afterwards it was a Mars map thing where they had to align the images and things like that.
Right, right.
I
guess that's different. So if you're going to do image registration with an extended object, like let's say something that fills the frame of an image camera, like
Yeah.
topography, things like that. The registration is probably different. Maybe the filters that you use, the edge detection filters, things like that you use to actually rotate and register the image are probably different. It's got to be mapped onto a sphere or a spheroid kind of thing. So in that ways it's different, but it's no different than what we do with Earth imaging or other planetary imaging.
No.
So I don't know that it's going to improve much, is I guess my response to that. Yeah, so Cosmo Quest had a role to play with Bennu, and I forgot what they had done, but I think they helped identify some places to go down and land on that dissolution. So,
yeah, that was a while ago as well.
And Arctuvus is saying the same thing you are, Peter, that Cosmo Quest does a record-breaking job of mapping Bennu. So that's what they were doing, I guess.
Yeah.
Jimmy Dugan, hey, it's good to see you from Australia. I'm always amazed when you show up because it's really like very early for you in the morning. So I'm glad you're here. And then of course Zoran shows up sometimes too. He's also from Australia. So
7 a.m. or something.
Yeah, it's really
in Australia.
So anyway, I guess you guys are used to doing things early in the morning. If you follow any social media on from the United States or whatever. But anyway, welcome. I'm always glad to see you, Jimmy. I hope you don't mind I call you Jimmy, because I feel like I know you. Navigation is going to be a nightmare for NASA. How much collision damage is the problem going to take from small rocks that no one can see? Will it last? Navigation is going to be a nightmare for NASA. How much collision damage is the problem going to take from small rocks that no one can see? Will it last? I don't.
Well, Lucy.
I don't understand. I think. Yeah, I think you're talking about getting
probably shielded.
I think you're talking about getting.
Well, it's going to be traveling fairly quickly there too, right?
Even a grain of dust.
Oh, I see.
And the L4 and L5 points are it's not like the L1 or L2 points where there's stuff doesn't drift into it.
Yeah.
L5 and L4 will be attractors.
Yeah, but as I understand Lagrange physics, which isn't very much, they are gravitationally stable in the sense that they also, you have to kind of work to stay in them a little bit. They're gravitationally stable places, but they also, at least the L2 point, the way it was explained to me by John Aronson from Northrop Grumman.
And then we're out of here. Sorry, Bunny.
Yeah.
Sorry, I was listening to somebody. They also keep things like micrometeoroids out and other smaller pieces of debris out of them. That's one of the ways I understand Lagrange points. So, so maybe
L4 and L5 are actual wells. I mean, that's why we have the Trojan asteroids, and so even Earth has
stable. They're stable as a well, while L2 is more of the other way around, inverted. Is that right?
Yeah.
Okay. All right. Good. So I guess you're right, Jimmy. It is going to be a little bit of it's going to attract all kinds of stuff in there, including these small rocks that nobody can see. So it's a good concern. I don't know how you protect yourself against stuff like
that. You take your chances.
I guess. So I don't know. So how well is the probe protected from micrometeorites? I don't know, Dennis. I mean, basically what I've learned about this mission was I spent looking up stuff on the web. If I look at the Wikipedia page on this, I mean, anybody can kind of do this stuff, but let's see, development, payload, and that's about it. So I'd have to read this more carefully to see if there was anything. So let's see, but at the Trojan cloud, where it will visit the binary Trojan Patroclus and Miniotis. The mission may end with the Patroclus Miniotis flyby, but at that point, Lucy will be on a stable 6-year orbit. That's right, I heard about this. It will go back to the L4 and L5 points every 6 years. It'll be in an orbit that lets it revisit these areas all the time. So I predict that if it doesn't get hit by something or damaged by something that causes the mission to end, NASA will keep this going for as long as the space probe works. It doesn't sound like it's got an RTG on it, so it looks like it's all solar power, which is a good and a bad thing. It can keep things going indefinitely as long as the solar panels don't get hit. And you're right, I don't know how, but I don't see how well they can protect against that. Solar panels are probably one of the more uh, vulnerable things on a spacecraft like that. So it's all a matter of hoping for the best, I guess. But I don't know how. It doesn't say. I'm sure everything has been hardened that can be hardened on the spacecraft bus, for example, and the instrumentation bus. But whether they can do much to protect the solar cells, I doubt it.
It's pretty sparse out there, though. I mean, it's like when the galaxies collide in 5 billion years. The chances of a star-to-star collision is going to be, astronomical. Yes, it could happen, but probably not. And I think that we're talking about the same kind of thing there. Space is pretty big there, and even though they're we're going to a denser part, but it's still pretty sparse. So yeah,
And I think
the risk is there.
The middle regions of Andromeda is quite sparsely populated with stars as well. It's just the absolute inner part and the outside. So
Yeah,
if it's head on, we should be reasonably okay.
Yeah, we're not. Space is vast, and these things are small.
Yeah,
I think you got a good point. I mean, I think that the
we'll
density
be able to detect it if that by then.
The density.
You would think.
Well, we just won't.
Yeah, we would be able to detect if there was a star on a direct course for a star by then, and we'll have plenty of time.
Wait a minute, what are we talking about? Are we talking about micrometeorites hitting Lucy or stars hitting the galaxy?
Oh yes, but it's the same concept.
Oh, you're talking about galaxy mergers. Oh, I was like, what is he talking about? Okay, I get it now. So you're talking about when the Andromeda Galaxy and the Milky Way Galaxy merge, or when they collide, the stars won't actually hit. Okay, yes.
Yeah.
But I thought we were talking about micrometeorites at the at the L2 or the L3 or 4 and 5 points around Jupiter. So sorry. Okay, but Tony's point is well taken. There is
programs and asteroid belts and stuff. It doesn't work like that. None of it works like that. They are very far apart.
But you still,
you might get grains of dust, but that's about it.
And that's what we're worried about here: micrometeorites or dust and things like that. So it could happen, but I don't know how you would protect yourself from it other than just doing the best you can with the hardening that you've got. And the most solar panels that they launch on spacecraft these days can take a certain amount of damage before they stop working altogether, so that they can get hit and they'll still work. It's just it's up to a point at least.
Lucy won't be dodging boulders or anything. We don't have to worry about that.
Yeah. So weather looks good for a 5:30 launch. Yes, in Florida. We've had a lot of good weather here lately, so probably true. I don't know that for me to get there at 5:30, I've got to get up at 4:30 or 4 o'clock and get there. It's about an hour and 10 or 15 minutes for me to drive there. I might do it, but I probably won't, if I'm being honest. I mean, I don't see sunrises very often unless I have been up all night. That's the only time I see a sunrise. Okay, so Cryptolicious, maybe they can send a suicide drone to escort Lucy and and take the hit when called upon. There, you go first, man. I'll be right behind you every step of the way. Grain to sand analogy. If the grains are 1 kilometer apart, yes, that's. And Architufus is commenting, dust traveling at 7 kilometers per second can do some serious damage. Yes. But like I say, I know that the solar panels, certainly on the ISS and other places like with Juno, for example, that's currently around Jupiter. That, of course, they did harden that spacecraft quite a bit to protect it from radiation, but they can take some damage with their solar panels before they stop working entirely. In fact, I have I speak from experience because I have many solar panels in my backyard. One of the panels, I noticed, every panel is made up of cells, and one of the cells in one of my panels has been fried, probably by a lightning strike. And I disconnected the panel. That was the collection of all those cells. I tested the voltage, and it was reading just fine. It was a small voltage drop of about 4 volts, which is what each of those cells puts out. So it had shorted, but it did not open the connection. So the panel was still working minus that one cell. A very similar thing could happen with we could imagine, with a rock going through it and putting a hole in one of the cells or one of the elements, whatever they are on a spacecraft, that generates electricity. That element will go down, but the rest of them surrounding that element should still work depending on the design. So solar panels can take some damage and still work, albeit at a slightly reduced capacity. And that's what happened with me in that one module that I have. Okay, Galaxia, let's see what she says. When Andromeda and Milky Way collide, it is estimated that one star collision will happen, and that's between 1 trillion stars for Andromeda and 500 billion for the Milky Way. So 1.5 trillion stars. That's right. So 1 out of 1.5 trillion are going to collide.
Which one, though?
Yeah, that's the question.
Which one?
Yeah, and that goes to a lot of statement that.
Or is that just the broad estimate? You know,
everything's.
Do we know which one, or is it an estimate?
It's an estimate. We're not going to know which exact one it is.
Yeah.
I don't think.
Yeah.
Not.
That's just the odds,
Yeah.
and it may not. None of them might hit, right? Or you might have.
Yeah, the odds of
I don't know. There's error bars in that.
The odds of an event happening
estimate
are much higher, are high, but the odds of a specific event happening to you are even higher. So you gotta take all of that.
It's a lot more than winning the lottery.
Yeah.
So put your tickets on.
All right. Well, guys, I got to go. So I want to thank you guys for joining, Peter and Tony. Thanks for joining the conversation. You guys are welcome as well. Get online, get onto the Discord server, and talk with me about stuff. And we will chat about things. It's fun for me to do this. I enjoy doing this. So please join me. I'll be back on Thursday, where I think I'm talking about lunar telescopes on the moon. The far side of the moon. So that'll be on Thursday. If you've got any questions, comments, and you can.
Well, it will be the best kind.
Right. And so I'm sorry, let me just get that cleared out. Okay. So I'll see you guys I'll see you guys on Thursday. Thank you so much for watching. And as always, keep looking up. The best part of waking up is Folgers in your cup. By the way, which one's pink? And don't always remember, don't ever forget the immortal words of Socrates, who said, I drank what? See you guys later. Bye.
Bye.